All right, so next type of problem we have on 8-2 practice, starting at number 11, is using the Pythagorean theorem's converse. So converse just means that I know what all three of my sides are of my triangle, but I don't know if it's a right triangle or not. So we're going to use Pythagorean theorem to determine what kind of triangle these three sides will make. So number 11, it gives us our three sides of 10, 11, and 20. Okay? So what that is going to kind of look like if we draw our triangle is 10, 11, and 20 here. Now the way I've drawn it, it looks like it's a right triangle, but just given three numbers, we don't know yet that they make a right triangle. All right? So the first thing we have to do is, let's make sure first, will those three values even make a triangle? So the way we do that, if you remember, is we choose your two smallest sides, so in this case 10 and 11, and we add those two together. And now we compare this number to our longest side. And in order to be a triangle, this sum, 10 plus 11 equals 21, has to be greater than this longest side of 20. If it's greater than, then we're good to go. We're ready to follow through with our problem. So let's go through and use Pythagorean theorem to check to see if these three numbers, since they do or will form a triangle, does it form a right triangle? So we're going to go back to a squared plus b squared is equal to c squared, where a and b are your two small sides, c is your longest side. If it is a right triangle, c is your hypotenuse. Okay? And what I'm going to do on top of my equal sign is I'm going to put a question mark here. Because at this point, just given these three numbers, I am not sure yet if it's a right triangle. So I put that question mark because this is what I'm going to test. Is a squared plus b squared, is that equal to c squared? So I go back to my numbers and I plug in, I substitute in my 10, 11, and 20. So my smallest value is my a, my middle value is my b, my greatest value is my c. And I'm going to keep that question mark here because I'm still working on determining if these two are equal or not. And instead of b here, I should have put, filled in my 11 squared since I know all three values. So now I'm just simply going to calculate the left side. And I'm going to calculate the right side and check to see are these two equal to each other. So on the left side, I've got 10 squared is 100 plus 11 squared is 121. Put my question here. And then the right side, I get 400. So now add these two, 100 plus 121 is 221. equals question mark 400. Once we get our calculations done, we compare these two, and no, they're not equal to each other. So this indicates that this is not a right triangle. All right? So what we're going to check next, since it's not a right triangle, then we have two other options. It's either acute or obtuse. Okay? So if it's not a right triangle, then it has to be either acute or obtuse. Well, the way we tell that is I always compare c squared to a squared plus b squared. If c squared is higher than a squared plus b squared, which is the case here, 400 is greater than 221, greater, larger implies obtuse. So that's why I always compare my c squared to the a squared plus b squared. Because if c squared is larger and obtuse mean the same thing. If c squared is less than a squared plus b squared, or smaller, that would indicate that it's acute. The only way it could be a right triangle is if your left side is equal to your right side. So your a squared plus b squared is equal to c squared.